This is the lecture video for section 6.1, video 6. Here we're going to talking about 4 examples, more like a complex examples involving inverse function properties. So the first one we're going to looking at is cosine of sine inverse of 2 over 3. So we can see from the expression we have 2 parts, the inner and then the outer. The inner part, I have a sine of inverse 2 over 3. This inverse function should return an angle. So I'm going to say this is going to be give me angle theta. And then I'm going to apply cosine to that angle, give me a particular number. So to do it, I'm going to breaking down into 2 parts. The first part is my theta equal to sine inverse of 2 over 3, the inner part. So because this is an inverse function, so I know that sine of theta equal to 2 over 3. 2 over 3 is not really a particular number. I can know what is theta equal to. So what I'm going to do next is I'm going to using this information to find what is cosine of theta using the Pythagorean theorem or the right triangle information. So if I have this is the theta in the right triangle, 2 over 3 tells me the adjacent side is 2, the hypotenuse is 3. And then my third side, I can use the square root of 3 squared minus 2 squared to find it, which is square root of 5. So cosine of theta, well, equals to the adjacent side, the third side x over the hypotenuse, which is equal to square root 5 over 3. Okay. One more thing we need to take into the consideration is the return for or the range for the inverse function. Sine inverse of 2 over 3, because it's a sine inverse, my range is going to be quadrant 1 or quadrant 4. Because it's 2 over 3, so my theta is going to be in quadrant 1. So since theta is in quadrant 1, that means cosine of theta is positive. So that square root 5 over 3 is the final answer. Okay, so the second example we want to check, or we want to know how to do it, is secant of cotangent inverse of negative 15 over 8. So we're still doing very similar things. The first, we're going to looking at the inside, which is a theta equal to cotangent inverse of negative 15 over 8. That means cotangent of theta equal to negative 15 over 8. Okay, so if you're not familiar, or if you're not feeling comfortable working with cotangent, you can change it to tangent of theta equal to negative 8 over 15. Since we have cotangent inverse of negative 15 over 8, and then cotangent, the range for the cotangent is going to be in quadrant 1 or quadrant 2. So that means theta is in quadrant 2. So so we can have a negative 15 over 8. So we're going to use this one later. So I have tangent of theta equal to negative 8 over 15. I have to using the triangle versions. So I have theta, tangent of theta tells me the adjacent one is 8. The one next to the angle theta is 15. I need to find the hypotenuse. Then the hypotenuse is going to be the square root of 8 squared plus 15 squared. And when we draw the triangles, we can ignore the negative sign for right now. So we end up with 64 plus 225, 289, which is 17 squared. So we got x equal to 17. Then secant of theta is going to be equal to 1 over cosine of theta. So cosine of theta, that is 15 over x. Then 1 over cosine of theta is going to be x over 15. So we end up with 17 over 15. However, we do need to take consideration of theta is in quadrant 2. When theta is in quadrant 2, cosine is negative. So secant is also going to be a negative. So the final answer is negative 17 over 15. Okay, so the next one we have is sine of arc tangent of 4 over 3 minus arc cosine of 12 over 13. So to find it, we're going to do very similar things, but this time we have two parts we need to figure out. Number one is the theta. Number two is we're going to applying the sum formula for the sine function. So I'm going to say arc tangent of 4 over 3 return me angle alpha. Arc cosine of 12 over 13 return me an angle beta. Or I'm just going to using A and B to matching the formula. So A and B. Okay, so because even though because we're not talking about the same angles here, we have two different inverse functions. So both arc tangent and arc cosine will return two different angles. So I'm just going to label it, one is A, one is B. So to find A, so I have A equals to arc tangent of 4 over 3. That means tangent of A equals to 4 over 3. So I'm going to draw a right triangle with angle A. Tangent of A, 4 over 3, tells me 4, 3, and then x. So I know x is going to be the 4 square plus 3 square, which is 5. Okay, so from here, I can have the following information. Sine of A equals to 4 over 5. Cosine of A equals to 3 over 5. Arc tangent of 4 over 3 tells me A is in quadrant 1. So both are positive. Second step, I'm going to do B. Arc cosine of 12 over 13 equal to B. So cosine of B equal to 12 over 13. Positive, so also in quadrant 1. Then I'm going to draw a right triangle with B. Cosine tells me 12, 13. Then x equals to square root of 13 square minus 12 square. 169, 144, 5. So from this analysis, what I know is sine of B equals to 5 over 13. Okay. Then the third step I'm going to do is finding sine of A minus B. I'm just going to adding one more step. So I want to find sine of arc tangent of 4 over 3 minus arc cosine of 12 over 13. Which if I do got A and B equal to, for example, 39 degree or 27 degrees, I can actually find them, but we can't. So I'm just using the A and B's to labeling them. Then I can use the formulas: sine of A, cosine of B, minus cosine of A, sine of B. So that's why you can see why I need to talking about the sine of A, cosine of A. I have the cosine of B, and then I need to figure out sine of B here. So sine of A equal to 4/5. Cosine of B equal to 12 over 13. Cosine of A equals to 3/5. sine of b equal to 513. So multiplying them together, I end up with 48, 65 minus 3 over 13. So 48 over 65. Actually, I shouldn't simplify it. Okay, so 15 over 65. So I end up with 33 over 65.